All right,
Go.
so here's the idea I had with the physics stuff. This being the accelerated graph, obviously, this was the one that we did previous that had constant velocity. The kids will really get, by the time that's over, that if I take the difference in the time from here to here, that I get an average velocity. Evaluating this is a little tougher for them because of the curve. So I think without too much difficulty, if I said, what if I took in this distance, let's say that this is 6 and 0, and draw a line like this, what can I do with that line? They seem pretty able to understand that that could give them the same information as this because this looks so much like this. So I'm saying like, this secant line connects 2 points in time on the graph. I'm getting it by evaluating a slope of it, so the difference between 2 points, I'm getting an average velocity. Now in some places my average velocity is far off, or my line is far off, in some places it's really close, but it seems like I can get an average velocity. Talk to them about shrinking the time intervals, and that in smaller time intervals we'd be more accurate. So if I went from, let's say to 4 seconds, that my line gets closer to the curve so that I'm more accurate than I was before. Ask questions like, so what would be the most accurate thing I could do? And they would say a really small time interval. Then I introduced the idea of how like instantaneous would be as small as we could get. So what came to me later was that the smart thing I should have done was say, all right, well, we're going to do an instantaneous at the halfway point, so at 3 seconds. If the average over this of 6 seconds ends up being 30 meters per second, let's say, I can draw this line that's an instantaneous, and since it only has 1 point, and I'm not connecting 2 points, it's only going to touch 1 point on my graph. So when I draw this line, it can only touch 1 point on my graph. Doing that, showing the kids that these lines are parallel, was something that I missed. So now going back and thinking like, okay, well this line is parallel to this line. So if I evaluate the slope of any 2 points on this line, what information should I find out? I should find out that this is also 30 meters per second, because if I have 2 parallel lines on a graph, they're going to have the same slope. So that was where I screwed up. And I think that now, like going back and introducing that concept of tangent and secant is better if I have, built into it, like I'm just connecting 2 time intervals. Now I've got a really small time interval, so it's just 1 point on the graph, and I can evaluate this line, and then connecting it back to these lines, because that seems to make sense. Okay, is that it?